Why do we multiply fractions such as 2/3 and 4/5, like multiply the numerators 2 times 4 and put the product 8 in the numerator of the product fraction, and then multiply the denominators 3 times 5 and put the product 15 in the denominator of the fraction? To begin, I think of 2/3 times 4/5 as 2/3 of 4/5. This region model shows 2/3 of 4/5. First, we need to find 4/5 by looking at the columns. There are 5 columns. There are 5 columns shown here. 1, 2, 3, 4, 5. And then to get 4/5, 4 of the 5 are filled in. Now, for the 2/3, we need to look at the rows. There are 3 rows and 5 columns. Notice that is the denominator for both fractions that we are working with, 3 and 5. That means that the denominator represents how many pieces there are. Now, going back to the number we filled in the first time, we will use those to find how many to fill for the 2/3. Now we are only looking at the part that we have filled in already because the goal is to find 2/3 of 4/5. So we are going to ignore this part of it when we are filling in the 2/3. Earlier we established that the thirds are represented by rows, so that is how we will shade the 2/3. Now that we have shaded the 2/3, we need to count how many of those are shaded. 1, 2, 3, 4, 5, 6, 7, 8. We know that the numerator is how many are shaded, so that is why you can multiply across the top. The total number of pieces is the denominator, so now we need to go back to our original rectangle and cannot ignore the unshaded pieces. So now we are going to include these pieces when finding the denominator. Unlike when we were finding the numerator, we ignored these pieces. The total number of squares is 15. So that is why you can multiply straight across the denominators to find the correct answer. This method will work for any proper fraction. Here's the one we just did. 2/3 of 4/5, or 2/3 times 4/5 equals 8/15. I will now show you how with a generalized version of the table we previously did. This is the problem we will be working with now as a generalized version. Here is the model that we'll be working with. Previously, it was broken up based on the second denominator first, which in this case is D. So we are breaking up into D amount of pieces. Then we broke it into pieces based on the first denominator, which in this case is B. Here we are breaking it up into B pieces. We then begin to shade squares based on the numerator. In this case, the numerators are A and C. So we'll break it up to A pieces. Or we'll shade A pieces, and now we're shading C pieces. So now, this part here, the A pieces and C pieces is filled in. The filled in part is what we said the numerator was. This now shows us that the filled in part is A times C. A times C. The denominator we discovered was how many pieces it was broken into total. That is represented by B and D, which is what we started with, was breaking it up into pieces. So B times D. We have now discovered that when you multiply fractions, you can multiply straight across in any proper fraction to get the correct product. This will work with any proper fraction.